Okay, students, good morning. Today we do some question from class 10, illustrated optional mathematics, page 224. Topic is trigonometry, exercise 5.1b. Let's start from question number 1a. On 1a, the question is write sine A in terms of sine A by 2. Now it's also here sine A equal to 2 sine A by 2 dot cos A by 2 equal to 2 sine A by 2 cos A by 2, that is square root of 1 minus sine square A by 2. Now question number 1b. Write the relation between cos A and sine A by 2. Cos A and sine A by 2. Now its solution here. Cos A equal to 1 minus 2 sine square A by 2. Now 1c. Write cos A in terms of cos A by 3. Write cos A in terms of cos A by 3. Now its solution. Solution here. Cos A equal to whole cos cube A by 3 minus 3 cos A by 3. Okay, students, now we go to question number 2. Question number 2a. The question is find the values of sine A. Find the values of sine A, cos A, tan A, cos A, tan A, and cot A if first question is sine A by 2 equal to 3 by 5. Sine A by 2 equal to 3 by 5. Number 2, tan A by 2 equal to 5 by 12. Now its solution. Here for I, sine A by 2 equal to 3 by 5. We have to find sine A. To find the values of sine A, cos A, tan A, and cot A. Now cos A by 2 equal to square root of 1 minus sine square A by 2 equal to square root of 1 minus sine square A by 2, that is 3 by 5 whole square. equal to square root of 1 minus 9 by 25. Square root of 25 minus 9, 16 by 25 equal to 4 by 5. Then sin A equal to 2 sin A by 2 into cos A by 2. Now we can put the value of sin A by 2 and cos A by 2. 2 into sin A by 2, that is 3 by 5, into cos A by 2, that is 4 by 5. This equal to 4 3 12 to the 24 upon 5 5 the 25. So value of sin A is 24 by 25 for 2. Cos A equal to 1 minus 2 sin square A by 2. 1 minus 2 sin square A by 2, that is 3 by 5 whole square, equal to 1 minus 2 into 9 by 25. 25 9 to the 18, 1 minus 18 by 25 is equal to 25 minus 18, that is 7, equal to 7 by 25. This is value of cos A. Then tan A. Number 3. Tan A equal to sin A upon cos A. The value of sin A is 24 by 25. 24 by 25. Upon value of cos A is 7 by 25. 25 cancel. So 24 by 7. And number 4, cot A. Cot A equal to 1 upon tan A. 1 upon value of tan A is 24 by 7. This equal to 7 by 24. Value of cot A is 7 by 24. Okay, students, now we go to next question, 2b. Number 2a. Now for IN, for second part, IN. Here for IN, 10 a by 2 equal to 5 by 12. To find the values of sin A, cos A, tan A, and cot A. Now sin A equal to 2 tan A by 2 upon 1 plus tan square A by 2. Now put the value of tan A by 2. Value of tan A by 2 is 5 by 12, so 2 into 5 by 12 all upon 1 plus 5 by 12 whole square. This equal to 5 to the 10. 10 by 12 all upon 1 plus 25 by 144. This equal to 10 by 12. 10 by 12 upon 144 plus 25, 169 upon 144 equal to 10 by 12 into 144 upon 169. Now it becomes 120 by 169. 120 upon 169. And we have to find value of cos A. Cos A equal to 1 minus 10 square A by 2 all upon 1 plus 10 square A by 2. 1 minus 10 A by 2, 5 by 12. So 10 square A by 2, 5 by 12 whole square all upon 1 plus 5 by 12 whole square is equal to 1 minus 25 by 144 all upon 1 plus 25 by 144. This equal to 144 minus 25. We can use calculator. 144 minus 25. 119. 119 by 144 all upon 169 by 144 is equal to 119 by 169. This is the value of cos A. Now third is tan A. Number 3, tan A equal to sin A upon cos A. Sin A upon cos A. Value of sin A is 120 by 169. 120 by 169 upon value of cos A is 119 by 169 is equal to 120 by 119. Number 2, cot A. Cot A equal to 1 upon tan A. 1 upon 120 by 119. This equal to 119 upon 120. Okay, students, number 2 is also completed. Now we go to next question, 2b. On question number 2b, the question is, in each of the following conditions, in each of the following conditions, find the values of cos A, cos A, cos A, cos A, and cot A. Number 1, sin A by 3 equal to 4 by 5. Sin A by 3 equal to 4 by 5. Number 2, cos A by 3 equal to 2 by 3. Cos A by 3 equal to 2 by 3. Now solution here for I. Sin A by 3 equal to 4 by 5. To find the values of cos A, cos A and cot A. Now cos A by 3 equal to square root of 1 minus sin square A by 3 equal to square root of 1 minus sin square A by 3, that is 4 by 5 whole square equal to square root of 1 minus 16 by 25 equal to square root of 9 by 25 equal to 3 by 5. Cos A by 3 equal to 3 by 5. Then for I, cos A. Cos A equal to 4 cos cube A by 3 minus 3 cos A. 3 cos A by 3. 4 into cos cube A by 3, that is 3 by 5 whole cube. Minus 3 into cos A by 3, 3 by 5 equal to 4 into 9 by 27 by 125 minus 9 by 5. 27 for the 108 upon 125 minus 9 by 5. Now this equals to 108 by 125 minus 9 by 5 minus 117 upon 125. Then for 2 cos A for 2 sin A equal to 3 sin A by 3 minus 4 sin cube A by 3 equal to 3 sin A by 3. Value of sin A by 3 is 4 by 5. So 3 into 4 by 5 minus 4 into 4 by 5 will give 2 by 5 minus 256 upon 125. Now it becomes 12 by 5 minus 256 upon 125. That is 44 upon 125. 44 upon 125. After this, therefore, cos A equal to 1 upon sin A. 1 upon 44 upon 125 equal to 125 upon 44. That is value of cos A. Now number 3, we have to find the value of cot A. Again for 3. Again for 3. Cot A equal to cos A upon sin A. Value of cos A is minus 117 by 125. Minus 117 upon 125 upon value of sin A. Sin A is 44 by 125. 44 by 125. This equal to minus 117 upon 44. This is the value of cot A. Now we have completed the first part. Again, remain second part. Let's do second part. For second part, for II, we have cos A by 3 equal to 2 by 3. To find the values of cos A, cosec A, and cot A. Now for 1, cos A equal to 4 cos cube A by 3 minus 3 cos A by 3 equal to 4 into cos cube A by 3, that is 2 by 3 whole cube. 2 by 3 whole cube minus 3 into cos A by 3. 3 into 2 by 3. This equal to 8 for the 32 upon 3 cube is 27 minus 3 to the 6 by 3. Now this equal to 32 divided by 27 minus 6 divided by 3 minus 22 by 27 minus 22 upon 27. This is the value of cos A. Now second part, cosec A. Number 2, cosec A. Sin A by 3 equal to square root of 1 minus cos square A by 3 is equal to square root of 1 minus cos A by 3, that is 2 by 3. So 2 by 3 whole square. 1 minus 4 by 9. 9 minus 4, 5. Square root of 5 by 9 equal to root 5 upon 3. Then sin A. Sin A equal to 3 sin A by 3 minus 4 sin cube A by 3. 3 into sin A by 3 root 5 by 3, so root 5 by 3 minus 4 into sin cube A by 3 that is root 5 by 3 whole cube equal to 3 root 5 upon 3 minus root 5 whole cube, that is 5 root 5. 5 for the 20, so 20 root 5 upon 3 whole cube is 27. Now it becomes 3 root 5 divide 3 minus 20 root 5 divided by 27. 7 root 5 by 27. 7 root 5 by 27. Therefore, after this, therefore, cos again equal to 1 upon sin A equal to 1 upon 7 root 5 upon 27 equal to 27 by 7 root 5. This is the value of cos A. Now, third question, we have to find cot A. Number 3, cot A equal to cos A upon sin A. The value of cos A is minus 22 by 27. Minus 22 upon 27. Value of sin A is 7 root 5 upon 27. 7 root 5 upon 27. So this equals to minus 22 upon 7 root 5. This is the value of cot A. Now we go to next question. Question number 3A. Question number 3A. The question is, if cos 30 degree equal to root 3 by 2, so that number 1 sin 15 degree equal to root 3 minus 1 1 upon 2 root 2. Number 2, tan 15 degree equal to two minus root 3. Now its solution. Solution here, cos 30 degree equal to root 3 by 2. To prove cos sin 15 equal to root 3 minus 1 whole upon 2 root 2. Number 2, tan 15 equal to 2 minus root 3. Now for 1, we know that cos V equal to 1 minus 2 sin square A or 2 sin square A equals to 1 minus cos 2A or sin square equals to 1 minus cos 2A all upon 2. Putting A equals to 15 degree, we get sin square 15 degree equals to 1 minus cos 2 into 15, that is 30 degree all upon 2. Or sin 15 degree whole square equals to plus minus the square root of 1 minus cos 30 degree all upon 2 whole square or sin 15 degree equals to plus minus square root of 1 minus cos 30 1 minus cos 30 degree all upon 2 equals to plus minus, we have the value of cos 30 root 3 by 2, so putting value 1 minus root 3 by 2 all upon 2 is equal to plus minus 2 minus root 3 all upon 2 to the now this equal to plus minus square root of 2 minus root 3 both multiplied by 2 by 2 into 2 by 2. This equal to plus minus square root of 2 to the 4 minus 2 root 3 all upon 8. Now this equal to plus minus square root of 4, that is 3 plus 1, so 3 minus 2 root 3 plus 1 all upon 8 equal to plus minus square root of 3 is root 3 whole square minus 2 dot root 3 dot 1 plus 1 is 1 whole square, making a square minus 2a plus b square form. To make perfect square, 8 is 8 all upon plus minus square root of root 3 minus 1 whole square all upon 8 is 2 root 2 whole square equal to plus minus root 3 minus 1 all upon 2 root 2. Since 15 degree lies in the first quadrant, since 15 degree lies in first quadrant, so value of sin 15 must be positive. So sin 15 equal to root 3 minus 1 all upon 2 root 2. So in first part all trigonometric ratios are positive. Now for 2. for 2. On 2 you have to prove tan 15 equal to 2 minus root 3. We know that tan square A equal to tan square A upon cos square A equal to sin square A, that is 1 minus cos 2A whole upon 2. Cos square A, that is 1 plus cos 2A whole upon 2. 2 to cancel out, equal to 1 minus cos 2A whole upon 1 plus cos 2A, or tan square A, or tan square A. Putting A equal to 15 degree on both sides, we get tan square 15 degree equal to 1 minus cos 2 into 15 cos 30 whole upon 1 plus cos 2 into 15 cos 30. Then tan 15 whole square, or tan 15 degree whole square equal to plus minus square root of 1 minus cos 30 whole upon 1 plus cos 30 is whole square. Therefore tan 15 degree equal to plus minus square root of 1 minus cos 30 whole upon 1 plus cos 30. Now we have the value of plus 30 root 3 by 2. So putting value equal to plus minus square root of 1 minus root 3 by 2 whole upon 1 plus root 3 by 2. Now taking LCM equal to plus minus square root of 2 minus root 3 whole upon 2, 2 plus root 3 whole upon 2. Denominator 2 to cancel out, remaining plus minus square root of 2 minus root 3 whole upon 2 plus root 3. Now this equal to, using conjugate of the denominator, we can get plus minus square root of 2 minus root 3 upon 2 plus root 3 into 2 minus root 3 upon 2 minus root 3 equal to 2 minus root 3 into 2 minus root 3, 2 minus root 3 whole square whole upon 2 plus root 3 2 minus root 3, that is 2 square minus root 3 square, 2 square minus root 3 square. Now this equal to plus minus square root of 2 minus root 3 whole square upon 2 square 4 root 3 square 3, so minus 3 plus minus square root of 2 minus root 3 whole square upon 4 minus 3 1. So this equal to plus minus 2 minus root 3. Square and square root cancel out. Square root of what is 1. Since 15 degrees lies in first quadrant, since 15 degrees lies in first quadrant, so the value of tan 15 degree must be positive. Value of tan 15 degree must be positive, and sine 15 degree equal to 2 minus root 3, taking positive sign. So it is proved. Now we go to next question. 3b. The question is, if cos 45 degree equal to, if cos 45 degree equal to 1 by root 2, verify that number 1 sin 22 whole 1 by 2 degree equal to 1 by 2 root square root of 2 minus root 2. Number 2 cos 22 whole 1 by 2 degree equal to 1 by 2 square root of 2 plus root 2. Okay, students, now its solution. Solution here. Cos 45 degree equal to 1 by root 2. To prove, number 1 sin 22 whole 1 by 2 degree equal to 1 by 2 square root of 2 minus root 2. Number 2 cos 22 whole 1 by 2 degree equal to 1 by 2 square root of 2 plus root 2. Now for 1, we know that cos 2a equal to 1 minus 2 sin square a, or 2 sin square a equal to 1 minus cos 2a, or sin square a equal to 1 minus cos 2a whole over 2. Putting a equal to 22 whole 1 by 2 degree, we get sin square 22 whole 1 by 2 degree equal to 1 minus 2 into 22 whole 1 by 2. This is 22.5 to the 45. So cos 45 degree whole over 2, or sin 22 whole 1 by 2 degree whole square equal to plus minus square root of 1 minus cos 45 degree whole upon 2 whole square. Therefore, sin 45 degree equal to plus minus square root of 1 minus cos 45 degree whole upon 2 plus minus we have the value of cos 45 degree, that is 1 by supporting value of cos 45 square root of 1 minus 1 by root 2 whole upon 2 plus minus square root of root 2 minus 1 whole upon 2 is equal to plus minus square root of root 2 minus 1 whole upon 2 into 2 by 2. Both numerator and denominator multiply by 2. This is equal to plus minus square root of 2 into root 2. 2 root 2 minus 2 whole upon 4. Here and then step 2 root 2, taking LCM root 2 into 2 root 2. Next step plus minus square root of root 2 minus 1 whole upon 2 root 2 into root 2 by root 2, rationalizing the denominator. Now it becomes plus minus square root of root 2 into root 2 2 minus root 2 into 1 root 2 all upon 2 root 2 into root 2, that is 4 equal to plus minus square root of 4 is 2, so 1 by 2 square root of 2 minus root 2. Since 22 whole 1 by 2 degree lies in first quadrant, so the value of sin 22 whole 1 by 2 degree must be positive. So sin 22 whole 1 by 2 degree equal to 1 by 2 square root of 2 minus root 2. So root. Hence root. Okay, students. Now we go to second part or 2. Now for II for 2, we know that cos A equal to 2 cos square A minus 1. So 2 cos square A equal to 1 plus cos 2A, or 2 cos square A equal to 1 plus cos 2A, or cos square A equal to 1 plus cos 2A whole upon 2. Putting A equal to 22 whole 1 by 2 degree, we get cos square 22 whole 1 by 2 degree equal to 1 plus cos 45 degree whole upon 2, or cos 22 whole 1 by 2 degree whole square equal to plus minus 1 plus cos 45 degree y whole upon 2 whole square. Therefore, cos 45 degree equal to square root of plus minus square root of 1 plus cos 45 whole upon 2. Here you are plus 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 plus. Since this lies in this, so the value of cos 92 over 1 by 2 degree must be positive. So cos 92 over 1 by 2 degree equal to 1 by 2 square root of 2 plus root 2. Hence proved. Now students, we go to next question. Question number 3C. Question number 3C. The question is, if cos 330 degree, if cos 330 degree equal to root 3 by 2, prove that number 1, cos 165 degree equal to 1 plus root 3 whole upon 2 root 2. 1 plus root 3 whole upon 2 root 2. Number 2, tan 165 degree equal to root 3 minus 2. Now its solution. Here cos 330 degree equal to root 3 by 2. To prove, number 1, cos 165 degree equal to 1 plus root 3 whole upon 2 root 2. Number 2, tan 165 degree equal to root 3 minus 2. Since cos 165 that is the second quadrant where the value of cos 165 must be negative, so this must be negative. In the second quadrant, the value of cos is negative. Now for 1, we know that cos 2a equal to cos square a minus 1, or to cos square a equal to 1 plus cos 2a, or cos square a equal to 1 plus cos 2a all upon 2. Putting a equal to 165 degree, we get cos square 165 degree equal to 1 plus cos 165 is a 330 all upon 2, or cos 165 degree whole square equal to plus minus square root of 1 plus cos 330 degree all upon 2 x whole square. Therefore, cos 165 degree equal to plus minus square root of 1 plus cos 330 degree all upon 2 is equal to plus minus square root of cos 330. We have the value root 3 by 2. So 1 plus root 3 by 2 all upon 2 equal to plus minus square root of 2 plus root 3 all upon 2 to the 4. This equal to plus minus square root of 2 plus root 3 whole upon 4. Both numerator and denominator multiply by 2. So this is equal to plus minus square root of 2 to the 4 plus 2 root 3 whole upon 4 to the 8 equal to plus minus square root of 4, that is 3 plus 1. So 3 plus 2 root 3 plus 1 whole upon 8 equal to plus minus square root of 3, that is root 3 whole square plus 2 dot root 3 dot 1 plus 1 whole square whole upon 8 equal to plus minus square root of root 3 plus 1 whole square, root 3 plus 1 whole square whole upon 8, 2 root 2 whole square equal to plus minus root 3 plus 1 whole upon 2 root 2 equal to plus minus 1 plus root 3 whole upon 2 root 2. Since 165 degree, since 165 degree lies in first quadrant, so the value of cos 165 degree must be negative. So cos 165 degree equal to minus 1 plus root 3 whole upon 2 root 2 hence proof. Again for second part. Again for 2. And 2 you have to prove 10 minus 65 equal to root 3 minus 2. We know that. Tan square A equal to sin square A upon cos square A, or tan square A equal to sin square A, that is 1 minus cos 2A whole upon 2 upon cos square A, that is 1 plus cos 2A whole upon 2, or tan square A equal to 1 minus cos 2A whole upon 1 plus cos 2A. Derivative to 2 cancel out, or tan A whole square equal to plus minus square root of 1 minus cos 2A whole upon 1 plus cos 2A its whole square, or tan A equal to plus minus square root of 1 minus cos 2A whole upon 1 plus cos 2A. Putting A equal to 165 degree, we get therefore tan 165 degree equal to plus minus square root of 1 minus cos 2A, 2 into 165 330, so cos 330 whole upon 1 plus cos 330 degree. Now we have the value of cos 330 degree, root 3 by 2. So this equal to plus minus square root of 1 minus root 3 by 2 whole upon 1 plus root 3 by 2 equal to plus minus taking LCM on both numerator and denominator. 2 minus root 3 all upon 2 all upon 2 plus root 3 all upon 2. Denominator 2 to cancel out, remaining plus minus square root of 2 minus root 3 all upon 2 plus root 3. Now multiplying by conjugate of denominator, we get equal to plus minus square root of 2 minus root 3 all upon 2 plus root 3 into 2 minus root 3 upon 2 minus root 3 using conjugate of denominator. This is equal to plus minus square root of 2 minus root 3 into 2 minus root 3. 2 minus root 3 whole square all upon 2 plus root 3 2 minus root 3, that is 2 square minus root 3 square equal to plus minus 2 minus root 3 whole square upon 2 square 4 minus root 3 square 3 plus minus 2 minus root 3 whole square upon 4 minus 3 1. Square root of 1 is 1. 2 minus root 3 whole square. Square and square cancel. Plus minus 2 minus root 3. Since 165 degree, 165 degree lies in second quadrant. So the value of tan 165 degree must be negative. So tan 165 degree equal to minus 2 minus root 3 equal to minus 2 plus root 3 equal to root 3 minus 2, hence proof. Okay students, now we have completed up to question number 3. Now we go to next question, question number 4. Now question number 4a we have. Question is, if sin a by 2 equal to a by 2 equal to 1 by 2 times p plus 1 by p, so that cos a equal to minus 1 by 2 times p square plus 1 by p square plus 1 by p square. Now its solution. Here sin a by 2 equal to 1 by 2 times p plus 1 by p. To prove cos a equal to minus 1 by 2 times p square plus 1 by p square. Now LHS equal to cos a. Cos a equal to cos 2 times of a by 2 equal to 1 minus 2 sin square a by 2, because cos 2 theta equal to 1 minus 2 sin square theta. Here theta is a by 2, so 2 sin square a by 2 equal to 1 minus 2. We have the value of sine a by 2, that is 1 by 2 times p plus 1 by p is whole square equal to 1 minus 2 into 1 by 2 square is 1 by 4, and p plus 1 by p whole square equal to 1 minus 2 by 4, that is 1 by 2. P plus 1 by 2 whole square, that is p square plus 2 dot p dot 1 by p plus 1 by p whole square is 1 by p square equal to 1 minus 1 by 2 p square plus p cancel plus 2 plus 1 by p square is equal to 1 minus 1 by 2 p square minus 1 by 2 minus 1 minus 1 by p square minus 1 by 2 p square plus 1 minus 1 cancel is equal to minus 1 by 2 p square minus minus 1 by 2 p square minus 1 by 2 p square. Taking minus 1 by 2 common, remaining p square plus 1 by p square equal to RHS group. Now, question number 4b. On 4b, we have sin a by 3 equal to sin a by 3 equal to 1 by 2 a plus a to the power minus 1, 1 by 2 a plus a to the power minus 1, then verify that sin a equal to 1 by 2 times a cube plus a to the power minus 3. Here sin a by 3 equal to 1 by 2 a plus a to the power minus 1 is equal to 1 by 2 a plus a to the power minus 1, that is 1 by a. To prove sin a equal to 1 by 2 a cube plus a to the power minus 3. Now calculus equal to sin a equal to sin 3 times of a by 3 equal to 3 sin a by 3 minus 4 sin cube a by 3, because we know that sin 3 theta equal to 3 sin theta minus 4 sin cube theta. Here theta is a by 3, so sin a by 3 sin cube a by 3. Now we have the value of sin a by 3, that is 1 by 2 times a plus 1 by a, so 3 times 1 by 2 a plus 1 by a minus 4 sin cube a by 3, that is 1 by 2 times a plus 1 by a, its whole cube Now this equal to 3 into 1 by 2, that is 3 into 1 by 2, a plus 1 by a, minus 4 into 1 by 2, that is 1 by 8, a plus 1 by a whole cube. This equal to 3 into 1 by 2, a plus 1 by a, minus 4 to the 8, so 1 by 2, a plus 1 by a whole cube. From these two terms, 1 by 2 common, remaining 3 times a plus 1 by a minus a plus 1 by a whole cube. Now 1 by 2 equal to 1 by 2, 3 times a plus 1 by a. Now a plus b whole cube, its formula is a plus b whole cube, that is a cube plus b cube plus 3ab a plus b. One by 2, 3 times a plus 1 by a minus formula of a plus b whole cube is a cube plus b cube is 1 by a cube plus 3ab a plus b, because a plus b whole cube equal to a cube plus b cube plus 3ab a plus b by using this formula. Now this equal to 1 by 2, 3 times a plus 1 by a minus a cube minus 1 by a cube plus minus a cancel, 3 times a plus 1 by a. First and last part cancel out, remaining 1 by 2 minus a cube minus 1 by a cube. This equals to minus 1 by 2 a cube plus 1 by a cube. So on the RHS, this must be, there must be minus sign, minus 1 by 2 a cube plus a cube by minus 3. This equal to minus 1 by 2 a cube plus a cube by minus 3 equal to RHS root. Okay student, now we go to next question, question number 5. On question number 5, A. Solution here to prove 2 tan alpha by 2 2 tan alpha by 2 all upon 1 minus tan square alpha by 2. This equal to tan alpha. Now RHS equal to tan alpha. Tan alpha equal to tan alpha by 2 plus alpha by 2. Tan A plus B form. So using formula of tan A plus B. Tan alpha by 2 plus tan alpha by 2 all upon 1 minus tan alpha by 2 into tan alpha by 2, because tan A plus B equal to tan A plus tan B all upon 1 minus tan A into tan B by this formula. Now tan alpha by 2, tan alpha by 2, adding together to tan alpha by 2 all upon 1 minus tan alpha by 2 into tan alpha by 2. It makes tan square alpha by 2 equal to LHS. Therefore, RHS equal to LHS. So proved. Now we go to 5B. On 5B, we have to prove sin alpha equal to 3 sin alpha by 3 minus 4 sin cube alpha by 3. Now LHS equal to sin alpha equal to sin taking alpha, that is 2 alpha by 3 plus alpha by 3. 2 alpha plus alpha, 3 alpha by 3, that is alpha. Now this equal to sin A plus B form. So use formula sin 2 alpha by 3 cos alpha by 3 plus cos 2 alpha by 3 dot sin alpha by 3, because sin A plus B equal to sin A cos B plus cos A sin B by d for of sin A plus B. Now this equal to sin 2 into alpha by 3 sin 2A form dot cos alpha by 3 plus cos 2 into alpha by 3 cos 2A form dot sin alpha by 3. Now using formula of cos 2A, sin 2A and cos 2A. Sin 2A to sin A cos, so 2 sin alpha by 3 dot cos alpha by 3 dot cos alpha by 3 itself plus cos 2A form. So 1 minus 2 sin square alpha by 3 dot sin alpha by 3, because sin 2A equal to 2 sin A into cos A and cos 2A equal to 1 minus 2 sin square A by adding this formula. Now this equal to 2 sin alpha by 3 cos alpha by 3 into cos alpha by 3. It makes cos square alpha by 3. Sin alpha by 3 into 1 plus sin alpha by 3 plus minus 2 sin square into sin alpha by 3, that is sin cube alpha by 3. Now this equal to 2 sin alpha by 3 cos square alpha by 3, that is 1 minus sin square alpha by 3 plus sin alpha by 3 minus 2 sin cube because cos square A equal to 1 minus sin square A. Now open bracket, this equal to 2 sin alpha by 3 minus 2 sin into sin square sin cube alpha by 3 plus sin alpha by 3 minus 2 sin cube alpha by 3. Now adding subtracting like comes 2 sin alpha by 3 plus sin alpha by 3, that is 3 sin alpha by 3 minus 2 sin cube alpha by 3 minus 2 sin cube alpha by 3, that is minus 4 sin cube alpha by 3 equal to RHS. So proved. Now we go to question number 6. On question number 6, again we have to prove the following identities. 6a. Also here to prove 1 minus sin A all upon cos A. 1 minus sin A all upon cos A is equal to 1 minus tan A by 2 all upon 1 plus tan A by 2. Now LHS is equal to 1 minus sin A all upon cos A. This 1 equal to sin square A by 2 plus cos square A by 2 minus sin A, that is half angle form, 2 sin A by 2 dot cos A by 2 all upon cos A, that is half angle form, cos square A by 2 minus sin square A by 2. This equal to cos A by 2 minus sin A by 2 whole square whole upon this equal to cos A by 2 plus sin A by 2. Here cos in the front part, so writing cos here in the front part. Cos A by 2 plus sin A by 2 A plus B, cos A by 2 minus sin A by 2 A minus B. Now cos A by 2 minus sin A by 2, this one cancel out, remaining other cos A by 2 minus sin A by 2 all upon cos A by 2 plus sin A by 2, dividing both the numerator and the denominator by the term cos A by 2. We get cos A by 2 upon cos A by 2 minus sin A by 2 upon cos A by 2 all upon cos A by 2 upon cos A by 2 plus sin A by 2 upon cos A by 2. Now it becomes cos A by 2 upon cos A by 2 1 minus sin A by 2 upon cos A by 2, that is tan A by 2 all upon 1 plus tan A by 2, that is our RHS. RHS proved. Dividing both numerator and denominator by cos A by 2 to 10 into 10. Now we go to the next question, 6b. On 6 6b we have to prove 1 minus cos A whole upon sin A equal to 10A by 2. Now we also equal to 1 minus cos A whole upon sin A. 1 minus cos A, that is 1 minus 2 sin square A by 2 half angle form whole upon sin A, 2 sin A by 2 dot cos A by 2 half angle form is equal to 1 minus 1 minus plus 2 sin square A by 2 whole upon 2 sin A by 2 dot cos A by 2. 1 minus 1 cancel out, remaining 2 sin square A by 2 whole upon 2 sin A by 2 dot cos A by 2. 2 cancel out, sin A by 2 cancel, remaining sin A by 2 on the numerator, cos A by 2 on the denominator. Sin by cos, that is 10 by 2 equal to RHS. So proof. Now next question, 6C. On C, we have to prove sin theta upon 1 plus cos theta is equal to tan theta by 2. Now we are just equal to sin theta upon 1 plus cos theta. Sin theta half angle form, that is 2 sin theta by 2 dot cos theta by 2 whole upon 1 plus cos theta half angle form, 2 cos square theta by 2 minus 1 is equal to 2 sin theta by 2 dot cos theta by 2 whole upon 1 minus 1 cancel, the remaining 2 cos square theta by 2. 2 to cancel out, cos theta by 2 cancel out. On the numerator, remaining sin theta by 2. On the numerator, remaining cos theta by 2. Sin by cos, that is tan theta by 2 equal to RHS. Proof. Now next question, 6D. On 6D we have to prove 1 plus cos x whole upon 1 minus cos x is equal to cot square x by 2. Now L is equal to 1 plus cos x whole upon 1 minus cos x. 1 plus cos x half angle form, 2 cos square x by 2 minus 1 whole upon 1 minus cos x half angle form, 1 minus 2 sin square x by 2. 1 minus 1 cancel, remaining 2 cos square x by 2 whole upon 1 minus 1 minus plus 2 sin square x by 2 equal to 2 cos square x by 2. 1 cancel, remaining 2 sin square x by 2. 2 cancel, cos square x by 2 upon sin square x by 2. Cos by sin, that is cot square x by 2 equal to RHS. Proof. Now next question, 6E. On 6 6a, we have to prove 1 plus sine alpha whole upon cos alpha is equal to 1 plus tan alpha by 2 whole upon 1 minus tan alpha by 2. Now we are just equal to 1 plus sine alpha whole upon cos alpha. This 1, that is cos square alpha by 2 plus sine square alpha by 2 plus sine alpha, that is halving alpha 2 sine alpha by 2 dot cos alpha by 2 whole upon cos alpha halving alpha cos square alpha by 2 minus sine square alpha by 2. A square plus b square plus 2ab, that is a plus b whole square. So cos alpha by 2 plus sine alpha by 2 is whole square. A square minus b square, a plus b minus b. So cos alpha by 2 plus sine alpha by 2, a plus b, and cos alpha by 2 minus sine alpha by 2, a minus b. So cos alpha by 2 plus sine alpha by 2, this and that cancel out, remaining on numerator or that cos alpha by 2 plus sine alpha by 2 on denominator cos alpha by 2 minus sine alpha by 2. Then dividing both the numerator and the denominator by term cos alpha by 2, we get cos alpha by 2 upon cos alpha by 2 plus sine alpha by 2 upon cos alpha by 2 all upon cos alpha by 2 upon cos alpha by 2 minus sine alpha by 2 upon cos alpha by 2, dividing numerator denominator by cos alpha by 2. Now this equal to cos by cos, this 1 plus sine by cos 10, 1 plus 10 alpha by 2 all upon 1 minus 10 alpha by 2, that is our RHS group. Now next question 6, yeah. On 6, yeah, we have to prove cos alpha equal to cot alpha by 2 minus tan alpha by 2 all upon cot alpha by 2 plus tan alpha by 2. Now RHS equal to cot alpha by 2 minus tan alpha by 2 all upon cot alpha by 2 plus tan alpha by 2 is equal to cot alpha by 2, that is 1 upon tan alpha by 2 minus tan alpha by 2 whole upon cot alpha by 2, that is again 1 by tan alpha by 2 plus tan alpha by 2. Now taking LCM on numerator and denominator both, it becomes 1 minus 10 into 10 tan square alpha by 2 whole upon tan alpha by 2 whole upon on denominator 1 plus tan square alpha by 2 upon tan alpha by 2. Tan alpha by 2, tan alpha by 2 cancel out, denominator part is equal to numerator 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. This is the formula of cos 2 alpha in half angle form, equal to cos 2 times alpha by 2, that is alpha, equal to LHS. Therefore RHS equal to LHS root. Now next question 6G. On 6G we have to prove 2 cos square a by 2 equal to sec a plus 1 whole upon sec a. Now RHS equal to sec a plus 1 whole upon sec a. Sec a is 1 by cos a plus 1 whole upon sec a is 1 by cos a. Making LCM unlimited, 1 plus cos a whole upon cos a, denominator 1 by cos a. Denominator by cos a cancel out, remaining 1 plus cos a upon 1, that is 1 plus cos a. 1 plus cos a half angle form, that is 2 cos square a by 2 minus 1. 1 cancel out, remaining 2 cos square a by 2, that is LHS. Therefore RHS equal to LHS. So proof. Now next question 6H. On 6H to prove 2 sin theta plus sin 2 theta whole upon 2 sin theta minus sin 2 theta. This equal to cot square theta by 2. Cot square theta by 2. Now LHS equal to 2 sin theta plus sin 2 theta whole upon 2 sin theta minus sin 2 theta. This equal to 2 sin theta plus sin 2 theta. Its formula is 2 sin theta dot cos theta. 2 sin theta into cos theta whole upon 2 sin theta minus sin theta again sin 2 theta. Its formula is 2 sin theta dot cos theta. On the numerator 2 sin theta common, remaining 1 plus cos theta. On the denominator 2 sin theta common, remaining 1 minus cos theta. 2 sin theta cancel out, remaining 1 plus cos theta whole upon 1 minus cos theta. Now 1 plus cos theta half angle form, 2 cos square theta by 2 minus 1 whole upon 1 minus cos theta half angle form, 1 minus 2 sin square theta by 2. Now this equal to 1 minus 1 cancel, 2 cos square theta by 2 whole upon 1 minus 1 minus minus plus 2 sin square theta by 2 equal to 2 cos square theta by 2 whole upon 1 minus 1 cancel, remaining 2 sin square theta by 2. 2 cancel out, cos square theta by 2 upon sin square theta by 2. Cos by sin, that is cot. So cot square theta by 2, that is RHS proof. Next question 6i. On 6i, we have to prove cos theta by 2 plus sin theta by 2 equal to square root of 1 plus sin theta. Now RHS equal to square root of 1 plus sin theta. For 1 we can put cos square theta by 2 plus sin square theta by 2 plus for sin theta copying up हम 2 sin theta by 2 into cos theta by 2. Now it makes a square plus b square plus 2a becomes so a plus b whole square. So here cos theta by 2 plus sin theta by 2 whole square, and square and square root cancel out, remaining cos theta by 2 plus sin theta by 2, that is LHS. Therefore RHS equals to LHS proved. Now next question 6j. On 6j we have to prove sin a by 2 dot cos cube a by 2, sin a by 2 dot cos cube a by 2 plus cos a by 2 dot sin cube a by 2. This equal to 1 by 2 sin a. Now LHS is equal to sin a into cos cube a by 2 plus cos a by 2 sin a by 2 into cos cube a by 2, cos a by 2 into sin cube a by 2. From these two terms we can take common sin a by 2 into cos a by 2 common, remaining cos square a by 2 plus sin square a by 2, but cos square a by 2 plus sin square a by 2, its value is 1. So sin a by 2 cos a by 2 into 1 equal to multiplying by 2 by 2, 1 by 2, then 2 sin a by 2 cos a by 2 is equal to 1 by 2. This is halving of sum of sin a, so 1 by 2 sin a equal to RHS group. In this step we have multiply by 2 on numerator and denominator 2 by 2. Now next question 7. I'll go to question number 7. On 7 we have to prove the following identities. 7a, so here to prove on a we have 1 minus 2 sin square, 1 minus 2 sin square, pi divided by 4 minus a by 2. This equal to sin a. Now LHS equal to 1 minus 2 sin square, pi divided by 4 minus 1 by minus a by 2. This is 1 minus 2 sin square theta form. This is for now cos 2 theta. So cos 2 here theta is pi divided by 4 minus a by 2, because 1 minus 2 sin square theta equal to cos 2 theta by using this formula. This equal to cos 2 into pi by 4, that is pi divided by 2 minus 2 into a by 2, that is a. Pi divided by 2 is 90 degree plus 90 degree minus a. Cos 90 minus a, that is sin a, equal to RHS group. Now we go to 7b. On 7b, we have to prove 10 pi divided by 4, 10 pi divided by 4 plus a by 2. This equal to sec a plus 10a. This equal to square root of 1 plus sin a whole upon 1 minus sin a. We have the three parts, LHS, middle term and RHS. Let's start from LHS. 10 pi divided by 4 plus a by 2. This equal to 10 pi divided by 4, that is 45 degree, plus a by 2. 10a plus b comes. So using formula of 10a plus b. 10a 1045 plus 10b 10a by 2 all upon 1 minus 1045 into 10a by 2. 1045 degree, its value is 1. So 1 plus 10a by 2 all upon 1 minus 10a by 2. Because 1045 degree equal to 1. Now this equal to changing into sin first. 1 plus 10 a by 2. This is sin a by 2 upon cos a by 2 all upon 1 minus sin a by 2 upon cos a by 2. This equal to cos a by 2 plus sin a by 2 all upon cos a by 2 all upon cos a by 2 minus sin a by 2 all upon cos a by 2. This denominator cos a by 2 cancel out, remaining cos a by 2 plus sin a by 2 all upon cos a by 2 minus sin a by 2. This multiplying by conjugate of denominator cos a by 2 plus sin a by 2 all upon cos a by 2 plus sin a by 2. Cos a by 2 plus sin a by 2. Cos a by 2 plus sin a by 2. Cos a by 2 plus sin a by 2 is all upon a minus b plus b. A square minus b square. Cos square a by 2 minus sin square a by 2. This is the formula of cos a in our angle form. So cos a, this a plus b will start from, that is cos square a by 2 plus sin square a by 2 a square plus b square plus 2ab 2 sin a by 2 dot cos a by 2. Its value is 1. Sin square a by 2 plus cos square a by 2 1 plus this is our angle form of sin a 1 plus sin a whole upon cos a. So 1 by cos a plus sin a by cos a equal to sec a plus 10, that is middle term. Sec a plus 10 a middle term. And after this again middle term equal to sec a plus 10 a equal to sec a 1 by cos a plus 10 a sin a by cos a equal to 1 plus sin a whole upon cos a equal to square root of 1 plus sin A whole square upon cos square A, taking square root and square equal to 1 plus sin A square root of 1 plus sin A b square whole upon cos square A is 1 minus sin square A is equal to square root of 1 plus sin A whole square. This is A square minus B square form, so 1 plus sin A into 1 minus sin A. 1 plus sin A, 1 plus sin A cancel, remaining non-numerator square root of 1 plus sin A, non-numerator remaining 1 minus sin A, that is RHS. Therefore, LHS equal to middle term MP equal to RHS. So, now we go to next question 7C. On 7C, we have to prove 210 pi divided upon 4, 210 pi divided upon 4 minus alpha by 2 whole upon one plus 10 square pi divided upon 4 minus alpha by 2. This is equal to cos alpha. Now LHS equal to 210 pi divided upon 4 minus alpha by 2 whole upon 1 plus 10 square pi divided upon 4 minus alpha by 2. Since this is the form of 210 theta upon 1 plus 10 square theta, this is the form of sin 2 theta. So sin 2 pi divided by 4 minus alpha by 2, because sin 2 theta equal to 210 theta upon 1 plus 10 square theta by this one term. Now this sin 2 into pi by 4, that is pi divided by 2. 2 into alpha by 2, that is minus alpha. Pi by 2, that is 90 degree. Sin 90 degree minus alpha, that is cos alpha equal to RHS proof. Now we go to next question 7D. On 7D, we have to prove 10 a by 2 minus pi divided by 4. 10 a by 2 minus pi divided by 4 minus cot a by 2 minus pi divided by 4. This equal to sin A sec A. To sin A into sec A. Now LHS is equal to 10 a by 2 minus pi divided by 4 minus cot a by 2 minus pi divided by 4 is equal to 10 a by 2 minus pi divided by 4 minus cot, that is 1 by 10 a by 2 minus pi divided by 4. Taking formula of 10a minus b, 10a minus 10b, 10a minus 10b whole upon 1 plus 10a into 10b, 10a by 2 into 10 pi divided by 4 minus cot a minus cot b, cot b cot pi by 4, cot b cot a by 2 minus 1 upon cot b cot pi by 4 plus cot a by 2. Now this equals to 10 a by 2, 10 pi divided by 4, 10 45, which value is 1 minus 1 upon 1 plus 10 a by 2 minus cot pi divided by 4, cot 45, which value 1. So cot a by 2 minus 1 whole upon 1 plus cot a by 2, because 10 pi divided by 4 equal to 1 equal to cot pi divided by 4, this also 1. Now this equals to 10 into sin cos, 10 a by 2 sin a by 2 upon cos a by 2 minus 1 whole upon 1 plus sin a by 2 upon cos a by 2 minus cos a by 2 upon sin a by 2 minus 1 whole upon 1 plus cos a by 2 upon sin a by 2. Now taking LCM, cos a by 2 cancel out, remaining sin a by 2 minus cos a by 2 whole upon cos a by 2 plus sin a by 2 minus taking LCM sin a by 2 cancel, remaining cos a by 2 minus sin a by 2 whole upon sin a by 2 plus cos a by 2. Since denominators are same, so taking LCM is sin a by 2 plus cos a by 2 on the numerator, sin a by 2 minus cos a by 2 minus cos a by 2 minus minus plus sin a by 2 is equal to sin a by 2 plus sin a by 2 to sin a by 2 minus to cos a by 2 whole upon sin a by 2 plus cos a by 2 is equal to 2 sin a by 2 minus cos a by 2, taking 2 common on the numerator, on denominator sin a by 2 plus cos a by 2. Now using conjugate of denominator, equals to cos a by 2 minus sin a by 2 whole upon cos a by 2 minus sin a by 2. On denominator cos a by 2 minus sin a by 2, cos a by 2 plus sin a by 2, it becomes cos square a by 2 minus sin square a by 2. On numerator 2 cos a by 2 minus sin a by 2 multiplying sin a by 2 into cos a by 2. Sin a by 2 cos a by 2 and minus sin square a by 2 minus cos square a by 2 becomes on the remainder cos square a by 2 minus sin square a by 2. Cot a minus b. Cot a minus b equal to cot a plus 1 upon cot b minus cot and minus plus minus plus and minus then plus minus. Now it becomes this equal to taking LCM sin a by 2 minus cos a by 2 whole square, sin a by 2 minus cos a by 2 whole square minus cos a by 2 plus sin a by 2 whole square 1 upon cos a by 2 here we can take this sin j plus then cos a by 2 minus sin a by 2. Then it becomes LCM cos square a by 2 minus sin square a by 2 then cos a by 2 sin a by 2. And sin a by 2 minus cos a by 2 then sign change here minus plus then cos a by 2 minus sin a by 2. Now this equal to in numerator cos square a by 2 minus sin square a by 2 on numerator this sin a by 2 cos a by 2 minus cos square a by 2 minus sin square a by 2 minus sin a by 2 minus cos a by 2 whole square plus cos a by 2 plus sin a by 2 whole square. Now it becomes Sin square a by 2, cos square a by 2 cancel out, remaining minus half plus 2 sin a by 2 cos a by 2, here also 2 sin a by 2 cos a by 2 remaining, all upon cos square a by 2 minus sin square a by 2 cos a, 2 plus 2 4, 2 into 2 sin a by 2 cos a by 2 all upon cos a, 2 sin a by 2 sin a by 2 cos a by 2 halving of that is sin a upon 1 by cos a, that is 2 sin sec a, 2 sin a sec a, that is RHS proved. Okay students, now next question. Seven A. On 7A, you have to prove cos square pi divided by 4. Cos square pi divided by 4 minus a by 2 minus sin square pi divided by 4 minus a by 2. This is equal to sin a. Now we have just equal to cos square pi divided by 4 minus a by 2 minus sin square pi divided by 4 minus a by 2. This is cos square theta minus sin square theta. So its formula is cos 2 theta. So cos 2 here theta is pi divided by 4 minus a by 2, because cos square theta minus sin square theta equal to cos 2 theta. Now cos 2 into pi by 4, that is pi by 2 minus 2 into a by 2 a. Pi divided by 2, that is 90 degree, cos 90 degree minus a equal to sin a, equal to RHS proved. Now we go to next question. 7. Yep. On 7, yep, we have to prove sec pi divided by 4, sec pi divided by 4 plus a by 2 into sec pi divided by 4 minus a by 2 is equal to 2 second. Now LHS equal to sec pi divided by 4 plus a by 2 dot sec pi divided by 4 minus a by 2. Sec is 1 by cos, so 1 by cos pi divided by 4 is 45 degree, 45 degree plus a by 2 dot cos 45 degree minus a by 2 equal to 1 all upon cos a plus b, cos a cos b, cos 45 cos a by 2 minus sin 45 sin a by 2, cos a cos b minus sin cos a minus b comes, so cos 45 cos a by 2 plus sin 45 sin a by 2 by the formula cos a plus b and cos a minus b. This equals 1 all upon a minus b, a plus b, so a square minus b square, so cos square 45 degree cos square a by 2 minus sin square 45 degree sin square a by 2. Now putting value of sin 45 cos 45 1 by root 2, so 1 by root 2 whole square cos square a by 2 minus 1 by root 2 whole square sin square a by 2. is equal to 1 whole upon 1 by root 2 square is 1 by 2. 1 by 2 cos square a by 2 minus 1 by 2 sin square a by 2. 1 whole upon 1 by 2 common, cos square a by 2 minus sin square a by 2. These 2 move up, so 2 upon cos square a by 2 sin square a by 2. Cos square minus sin square a by 2, that is cos a in half angle 2 by cos a, that is 2 sec a. We got RHS. Okay students, this much for today. Have a nice time. See you soon.